Let's quickly illustrate a few string manipulation methods. Very first one is getting the string length. You've seen this a few times when we take an existing string instance at runtime, initialized to welcome to Java in this case. This is a reference object. In Java, you will use the dot operator, reference object dot, the method name, to evoke that method, which takes no parameters in this case, and returns the length of that message. So you will count the number of characters you have here. 1, 2, 3, 4, 5, 6, 7, 8. Spaces counted as one character. 9, 10, another space. 11, 12, 13, 14, 15. The length of the message is welcome to Java is 15. And notice this plus operator. This is actually a method. In C++, these are overloaded operator. In Java, these are the concatenation operator that concatenate or combine these messages together. And when you system out print line, you're printing out the value of the message, which is welcome to Java, along with this string literals, which is the string constants that you hard code them into a system out print line. This is also a string literal. Let's look at some other examples. String concatenation. String concatenation in Java is the process of combining two or more strings or string instances to create a single string. There are multiple ways to concatenate strings in Java. Using the plus operator in the previous slide is one of the methods. There's also concat, which is short for concatenation method. This is a very commonly used method for concatenating two string instances, S1, S2. The equivalent of S1.concat S2 is the same as writing S1 plus S2. You already saw this is a print line where we use pluses. If you have more than two string instances that you wish to concatenate using concat, you can use S1.concat S2.concat S3. Yes, you can chain these. The order evaluation happens from left to right, which means S2 is concatenated to S1, and that combined string is then concatenated to S3. What if the instance to be concatenated is not a string instance? You can do that as well with plus sign. It turns out these plus signs supports different types as well. If what you have on the right side of your plus sign is an integer, this integer will be converted into a string. So you end up with a string instance, chapter 2. Same thing with concatenating a char. This char will be converted into a string B. So what you end up with, a string instance, supplement B. So these are nitty-gritties you'll learn as you go through the examples. Let's look at reading a string from the console. You had this before, using the scanner to read from standard input. This means from your keyboard in the examples we have. Supposedly, this is you have your console application. You'll set up your scanner object, and this is instantiated on the heap. We'll talk more about this dynamic memory allocations later. Suffice to say that you have an input object and you have a console out print asking the user to enter 3 words separated by spaces. Let's say Java, first word, is second word, fun, third word. And there's spaces in between, space, space, and hit enter. Now, in computer science, we call each of these words a token. So you actually have 3 tokens separated by spaces. Using input.next, you can also look it up. In the scanner API, since input is an instance of scanner, there is a next method which reads the very first token of the 3 words the user just entered. You can do another next, which reads the second token. So the first token goes here, the second token gets here, and the third token gets here. And they're stored inside S1, 2, and 3 respectively, and then you can print them out. This is a nice way of parsing, which means getting the tokens out of a whole bunch of text delimited by spaces. So this is one way of reading individual tokens or string words from the console. Let's look at getting characters from a string. This is a very popular method. We went over this a few times. you can use char at and specify the index location. Remember, your entire string instance is consist of these characters, and these are 2 bytes Unicode slots. Each of these slot is worth 2 bytes, and they store individual characters with index going from 0 all the way through length -1. So this welcome to Java has 15 characters, and the index location of each of these characters go from 0 to 14, or 15 -1. So char 0 is going to give you W, whereas char 14 or 15 -1 is going to give you the very last character of that string. Let's look at reading a character from the console. It turns out that instead of reading string instances from console at runtime, you can also read characters. You would invoke, instead of next, you will call next line. This reads the entire line of code the user just entered. Let's say Java is fun. Enter. That entire line, Java is fun, will be stored inside this input, which is a buffer. Technically, we call it string buffer. And then you can treat this entire string buffer as a string instance and perform char at 0. So this is going to give you J, because at index location 0, you'll get J. So just remember, char at is a very commonly used method in string, which outputs a char, a 2-byte Unicode. You can also use the concatenate, and this char will be converted into a string, and then you'll have the character enter is space J at the console.